Here's a possible answer.
No.
Nope, it's not 2.25 fish. That is definitely a wrong answer. Because you did not specify the unit. You're now leaving it to me to imply a unit. Well, I think you're talking about fish. Why do I think you were talking about fish? Because you didn't give me any information to make me believe that you weren't talking about fish. So I'm going to assume you were writing about fish. Does that now qualify as an answer to this question? Or is it a correct answer? No, that's actually wrong. Okay? So some people responded, okay, I understand where you're going with that. So, moles. That says moles. Okay? This is better. It's also wrong. Because I think you were talking about donuts. You were talking about 2.25 moles of donuts. I don't know why you're talking about donuts. The question has nothing to do with donuts. Why are you talking about donuts? You're wrong. You need to eat some food before you come to class. So your answer is still wrong. Right? There's more information that you have to specify. What are you solving for? The moles of oxygen. So there's two ways that we could go through and write this. You could, as kind of a cop-out, write oxygen. Okay? Fair enough, I'd accept that. Another way you could have written it would be by the symbol. This one's now wrong, though. It's O2. The only time we refer to a single atom of oxygen is when? When it says you're referring to atoms of oxygen. Does that say atoms of oxygen? No, it just says oxygen. Okay? Because oxygen is a diatomic element, we must be specifying it as O2. Right? And for those of you saying, well, that's nonsense, you didn't have to do that information, spell read. Right? The information, the context of those words has a lot of meaning. And if you remove that context, you remove the validity of that statement. You have to include it. Right? The same thing goes for everything that you write in this class. If you're asked to write an analysis about your kid's book, you shouldn't be talking about the weather. Why not? You're asked to write about kid's book. I don't care if it's a beautiful day outside. Does that have any meaning towards your kid's book? Right? At least there isn't an obvious link. If you were going to try and make that link, what would you have to do? You could write a kid's book about the weather. Right? Now, one of the things that your kid's book could rhetorically be trying to do is get kids to think about weather. And in that context, you may want to take them outside in that process of discussing your kid's book with them. Right? There's a logic behind the words that we choose and use. The same thing happens with chemistry. You need the logic. Right? So 2.25 moles of oxygen. Why is that a true answer? Where's the logic?
Because the nitrogen gas and oxygen gas are equal.
Okay. You're now adding an interpretation off of the information that's specified. Your answer, all you wrote, was this. Have you provided any logic? No. When you specify, because I know this chemical equation says that those two are 1 to 1, so if I know I have 2.25 1, the other one must be 2.25 to entirely react. That is an interpretation that you are doing. And that is a phenomenal interpretation that you are getting 0 credit for because you haven't proven that you know that. All that you've proven is that you can see a number that says 2.25, and you read the question to say that you should be writing moles of oxygen. I can't give you credit for that because you haven't proven that you understand more than just there's a number there and that you know moles of oxygen is your answer. Does that make sense? You have to show your work. Right? If you don't want to show your work, that is your choice, that is fine. You will lose lots of points. Right? And the reason behind enforcing showing your work is not because I expect you to get this question wrong. I expect you to get the next 4 questions wrong, where it requires you to show a lot more work and thought and development behind the process. Right? If you have to string together multiple things, you will start to fail. The question is do you have the process to allow you to not fail? That's what you need to be doing with these simple examples, is building the process, showing that work. The instant you do not show that work is the instant you get the question wrong. Okay? So what is that work? There's the approach that we've been taking to it, and we'll look at another approach here in a second too, because people have been struggling with that initial approach that we've been looking at, so we could try and come up with another way to do it. Okay, so what is our approach first? Step 1. Equals moles of O2. How do you know you should be solving for the moles of O2? Okay, so when you read the question, you're looking for this moles of oxygen. You aren't writing how many, but you're recognizing the visual cues of the written language to say that how many means an equals, and the moles of oxygen needs to be at your answer. Okay? You are reporting information. Okay? That's an awesome first step. That's what most starting writing classes do, report information. Can you report? Okay, what other information would we do? Step 2. Write out what we're given. What are we given? Okay. So we could box it in. We could look at visual design and how the visual design of this was awful because that given information splits across multiple lines. Okay. Is visual design such an important thing that every time we impact or write anything, we have to think about visual design and we have to incorporate it to its fullest level in our documents? Yeah? So every single one of you have made sure to use paragraphs in all of your essays? Made sure that you didn't have any punctuation errors, spacing issues, comma miscues. Those were all spotless and perfect? No. Visual design is important. It's something we need to think about. It can help us analyze things, but you're also in situations where you just can't have perfect visual design. So you have to be able to interpret an imperfect world. So the same things you're expecting Greg and I to do when we read your reports, analyze an imperfect paper and not completely ream you because you didn't include the proper number of spaces between the end of a sentence and the beginning of a sentence, right? You need to do when you read a question. Make sense? Okay, so we're given 2.25 moles of nitrogen. We've talked about the process on how we should incorporate that in. What should we start with? Moles of nitrogen. Why do we want to start with the moles of nitrogen and not the 2.25? The number ultimately doesn't matter. It's the unit that drives this. The number is the algorithmic thought process. Okay? You need to be coming up with the process behind the algorithm. So the unit is what drives this. Now I can put in a number. The thought process. Is moles of nitrogen the same thing as moles of oxygen? No, what's different? Nitrogen and oxygen. What is nitrogen as a thing? We've talked about it as a part of our measurement unit. What is that measurement unit? Or our unit, not measurement. Our unit has 2 pieces, a measurement and counting is a measurement. A substance. Okay? The unit is always composed of two pieces. You leave off any one piece, what's wrong? The whole answer. You need both. So when we look at this, moles versus moles, the measurement unit, which is a counting unit, is the same. But the substance unit has changed. Okay, so I need to do a substance conversion. Where do I find a conversion factor to convert substances? How do I build a bicycle? What's that? Two wheels and a frame. Okay, we could break it apart and look at the individual pieces that go into it. So we're saying those pieces come together to make a bicycle. You've built a recipe or a equation, a chemical equation. So if I'm going to convert substances, wheels into bicycles, I need the equation. How do I convert nitrogen into oxygen? The chemical equation shows the relationship between nitrogen into oxygen. The chemical equation does not need to be saying nitrogen becomes oxygen. Right? The chemical equation just needs to show the relationship between nitrogen and oxygen. That's it. Okay? When I put together a bicycle, wheels and frames, if I give you two wheels, how many frames do you need? One. Okay? Am I converting wheels into frames? Yes, you are. You are absolutely converting wheels into frames. Because you're saying that two wheels needs to go with one frame. Okay, so the term converting is just identifying that relationship. It's not saying that the frame now gets hammered into, or a wheel gets hammered into a frame. It's establishing that relationship. That's it. Okay? Are you related to your parents? Okay? Does that mean we could beat you up and turn you into your parents? No. Okay? But there's a relationship. We can look at that relationship to allow us to establish that conversion factor. Right? So we have to have a chemical equation. What units are associated with a chemical equation? I can think of 3 answers that I would accept. What do you got, QB? You started to raise your hand, I thought. Phase is not a unit. Phase is a description. What is the unit? I don't know what AU is. AMU. What is AMU? A mass. I give you 50 grams of bicycle tires. How many bikes can you make? Why can't you answer that? Because if AMU works for a chemical equation, when I take the mass of bicycle tires, I should be able to convert that into bikes. Why can't you come up with that conversion? Does the chemical equation, does a recipe tell you the mass of them? Yes. No. Yes? What is the weight of one bicycle tire?
Well,
if I had a conversion that allowed me to see the relationship between mass and a single bicycle tire, yes, it would be useful. The chemical equation does not tell you mass. What does it tell you? I know Allison knows the answer because she shouted it out earlier as one of the acceptable answers. What is the measurement unit associated with a chemical equation? Moles is a valid answer. 2 more. Molecules is a valid answer. What is the class of measurement unit that includes both moles and molecules? Counting. A chemical equation, any recipe gives you a count measurement. Okay? Moles and molecules work. Why do moles and molecules work for chemistry, but we wouldn't reference a tire as a mole or a molecule? What's that? Okay, that's physics. It's to do with the size of our particles. Okay? Tires are not the same thing as a molecule, because what goes into a tire? A whole bunch of molecules. Why would I not reference a mole of bicycle tires? That's a lot of bicycle tires. We probably actually don't have enough physical materials on the planet to make a mole of bicycle tires. Okay? That's how many bicycle tires that would be. Okay? So we're looking at a counting unit to convert the substance. Okay? So what we're saying is, number one, the substance has changed. I want N2 on the bottom. Why? So the unit cancels out. What do I want on top? O2. I've identified the substance conversion I want. I now need to specify the measurement unit associated with it. What measurement unit do I want to use? Moles or molecules? Why moles? Because the equation started me with moles. So moles probably make sense as a starting conversion. Could I go moles to molecules? Can I, so let me rephrase that. Can I go from moles of nitrogen to molecules of oxygen? No, why not? There's not a conversion factor for it. Why is there not a conversion factor for it? Different is a good start. What's different about those two units? Different substances and different measurements. You're changing too many things. You can't change both the measurement and the substance at the same time. Okay? Where do I find the relationship between the moles of oxygen and the moles of nitrogen? From the balanced chemical equation. Where's that information stored in the balanced chemical equation? What's that? What is the coefficient? Touche. Where's the coefficient located? To the left of each of those. What is the number specified there? It is an implied 1, which means now your work satisfies this. And for those of you saying, well, I got that answer already, you didn't get that answer because you didn't show the work. Okay? So your answer is invalid, period, full stop. You have to have that work. You have to prove the interpretation. Otherwise, all you are doing is copying somebody else's work. That is the only evidence I have, which means that's a 0 for the exam and grounds for failure and expulsion from the school. All of those things are horrible. You need the work to back it up. Okay? That is the process that I would recommend. Okay? We seem to be having some struggles with that, so is there another way to go through and do this? What does the chemical equation show us? What information does a chemical equation give you? It tells me the substance is used. What else does it tell me? What are the substances used? Nitrogen and oxygen gas. Are those the only things included in the chemical equation? No. So substances used is awesome. It's phenomenal. Yes, it absolutely tells me the substance is used. What else does it tell me? Not quite balanced. Maybe getting at the right idea, though. Coefficients is getting too nitpicky on it. You're now trying to zero in on specifics within this. What do those substances become when they're mixed? It tells me a product. Okay? A chemical equation tells me what substances do I mix, what substances do they become when they mix. Okay? That's what that information is. It gives me that. Okay? In this alternate method, we still have to be able to interpret where we're going, which is, we'll try and do it in an entirely different format. Where are we going? Okay, I want the moles of oxygen. Okay, where am I starting? The moles of nitrogen. How many moles of nitrogen am I starting with? 2.25 moles. Look at the chemical equation. How many moles of nitrogen am I starting with? 1. How do you know it's 1? Only look at the chemical equation?
There's no coefficients, that's just.
No coefficient is 1. Where am I starting? What am I starting with? 2.25 moles of N2. So instead of starting with 1, I want to go to 2.25 moles of N2. How do I go from 1 to 2.25? Okay, where am I trying to go to? What was my goal? I want to know what goes in that box. As I moved from the N2 down to where I ended up, what did I have to do? Multiply by times 2.25. What do I need to do for O2? The exact same thing. Times 2.25. What was the coefficient in front of O2? 1. What's my answer in the purple box? Thank you for following that up. I didn't see who did that, but that was good. Moles, oxygen. We now have a valid answer. This shows the exact same work as that was done before. You're now showing an interpretation of the chemical equation. The problem with this method is this is a single step. Right? If I have to do more steps, I have to set up more equalities, more expressions. The chemical equation is merely the same thing as saying 1 liter equals 1,000 milliliters if I'm given, oh god, and now I'm making that stupid mistake. How many liters would I have? How do I go from 1,000 to 23? Okay, so I start with 1,000 times something gets me 23. How do I do that? What is x? Times 23 by 1,000. To make that transition, what do I have to do over on the other side? Times 23 over 1,000. Okay? It's the exact same setup that we've been doing. You can break it down and show that the units all match, everything aligns. That works. I will accept that as work. Okay? I think that's a horrible idea and you're shooting yourself in the foot for longer questions. Okay? But if that's how you see it and that's how you want to manipulate it, that's fine. Okay? So, there's our work. So, next one. We saw this or a variation of this on your exam. Okay, for exam 2. For every 1 mole of oxygen consumed, 2 moles of water are produced, 9 grams of oxygen, 16 grams of oxygen equals 1 mole of oxygen are consumed, then how many grams of water are produced? 18 grams of water equals 1 mole of water. Okay. That was unit 2. Okay. Let's start to pull some reporting. Reporting information right here. What is that? If I try to convert that into a chemical, or not a chemical, an equality, a mathematical expression. As a hint, it starts with 1.00 moles of oxygen. Why O2? Oxygen is diatomic, and unless I specifically say atoms of oxygen, that's how it has to get written. Consumed means equals, 2.00 moles of H2O. There's an equality. Okay? What is being equated here? What is being changed across that equality? This is a substance conversion. Where do we find substance conversions? Not from a chemical equation, fully. For instance, given the rest of this information, H2 plus O2 becomes H2O. There's a chemical equation. This chemical equation doesn't seem to match that. How do we get a substance conversion? How do I make that equation match the equality? Coefficients. Coefficients? Well, the coefficients are all 1. That says 1 equals 2. So something's wrong. What's wrong? It's not balanced. If we balanced it, what's the number in front of oxygen? 1. What's the number in front of water? 2. How do we do substance conversions? From a balanced chemical equation. Okay? Because we're inherently all lazy, we don't want to write out all those words, so what do we write instead? Exactly, BCE, balanced chemical equation. Okay? What's the next equality? 16. What's being converted here? Okay, this is now a measurement conversion. Where's this measurement, or what measurement conversion is happening here? What are we relating? Grams and moles. Where do we find the conversion factor between grams and moles? On the periodic table. What was the next one? 18.0 grams of water, H2O equals 1 mole of H2O. What did we convert with that? What changed as we go from 18 grams of water to 1 mole of water? It's a measurement conversion. What measurement conversion are we doing? Grams to mole. Where do I find grams to mole? It's also on the periodic table. Okay. Are you responsible for knowing how to take the information in the question? 9 grams of oxygen are consumed when, well, this one was poorly written, are consumed when it reacts with hydrogen to produce water. Are you responsible for being able to convert that text into a chemical equation? Yes, which means what happens to the first equality? It's gone. You're responsible for figuring that one out. Are you responsible for recognizing, admittedly it's the wrong conversion, the mass of oxygen to moles of oxygen, and knowing that that is on the periodic table because you have the periodic table? Yes, which means that conversion is gone. And the last one is the same thing on the periodic table. So our question becomes, if 9 grams of oxygen are consumed, then how many grams of water are produced? Okay. I fixed it a little bit. Solve it. Show all the work. What are we trying to do? What is the goal? Okay, so I'm going to attempt to set this up so we can do it the other way. Grams of water. What am I given to start with? 9 grams of O2. Okay. What's my next step? Why are you trying to get grams converted into moles of O2? Okay, so I'm hearing a suggestion that we should do grams of O2, and I'm just guessing that you want to put it in the denominator and you want moles of O2 on top.
I second that suggestion.
Why do you want to do that?
Because
So grams cancels O2?
you need to convert. You're gonna need to find grams of H2O. If you find grams of H2O, you're gonna need to
So-
into moles of H2O to cancel out.
One argument that I would say for why you could start with this, so I can see 3 places on where we could go. The first argument for why we would start with this. Okay? Did anybody attend the stoichiometry workshop offered by the tutoring center to help you with this exact kind of problem solving? You might want to take advantage of the tools offered by the school to help you learn the material. How many of you have shown up to office hours so that I could help you learn how to solve these problems? You might want to take advantage of the tools offered to you that you are literally paying for and choosing to not use. Okay? Just putting that out there. If you went to the workshop, in that workshop, they tell you you should go to moles. Why should they tell, or why do they tell you to go to moles? Because in chemistry, moles are very, very useful. So as a blanket statement, if we go to moles, we are generally correct. So they're saying to convert to moles, and they're saying the reason you should convert to moles is that you're trusting us that we solved enough chemistry questions that you should just do what we say. That's an algorithm. You have no understanding for why you're doing it. Okay? You're trusting that somebody else has done enough things. Okay? Trust but verify. So I would argue that that is not a good thing to start with. Okay? For that reason. Because you're just saying, somebody told me the answer was to do this, so I'm doing what the answer said. The only reason you can get the answer right is because you knew the answer. That doesn't happen on an exam. Okay? The next way you could get into this is where I think Molly and Nick were potentially going, is that they recognize that the substance changed, and the only way to change the substance is through a balanced chemical reaction, and the units of a chemical reaction are in moles, so I need to go to moles. Is any of that noted by writing moles over grams? No. So it's not wrong, but you've internalized a lot of calculations. Those calculations are valid, and as long as you've internalized them correctly and continue to use them correctly, you're fine. The issue is the majority of you are not using them correctly. So those analyses are horrible pathways. So let's go back to the process that you were told to use time and time again. Left and right. Has the measurement unit changed? What is the measurement unit? Grams and grams. Has the measurement unit changed? No. Has the substance unit changed? Yes. How do I convert a substance? Through a balanced chemical reaction. So I would need to know what chemical reaction to do. Notice that there's no chemical reaction actually written out for me. So I have to rely on that stuff from Unit 2 where we said these are chemical reactions and the words and the names and the pieces and this is how they go together and this is how you're supposed to interpret it. I need those skills. If I don't have those skills, the very next step here I can't do. Okay? We're building on those old skills. So let's look at a balanced chemical reaction. So I can read the question and see that it says oxygen gas is reacted with hydrogen gas. That would suggest that those two species are reactants. They're mixed together. So I could write out oxygen gas and hydrogen gas, but that's too many letters and words and I don't want to write all that out, so I will write out their symbols. And I have to remember that the symbols for oxygen gas is O2. And if we really want to get nasty and nitpicky, because I'm getting nasty and nitpicky, you might as well be counter back. We have to specify the phase. Okay? Is the phase really going to matter? No. But if we're going to be accurate, might as well. Okay, it reacts with hydrogen gas. And I know that symbol to be H2. Why is it 2, Ethan? No. Okay, and I know I'm being a bit of a jerk. I'm calling because this was the mistake that you made. Why is it H2, Kiwi? Hydrogen's a diatomic element. Just like oxygen, oxygen must be O2, hydrogen must be H2, which is why you've got some calculation missteps. Your work is beautiful, but you missed that part. Okay? So, H2, well, how would I know hydrogen's supposed to be diatomic? I have to have it memorized. How have you memorized these? What did you decide? It's the hockey puck. Okay? It's the 7 elements, starting with nitrogen, oxygen, fluorine, chlorine, bromine, iodine. There's my hockey stick. But that's only 6 elements, and I know that the shape of that is 7. Oh, the 7th is hydrogen floating around as a hockey puck. Okay? So hydrogen is diatomic. The other way was... Really? Nobody remembers? Have no fear of ice cold beer? Oh, nobody seems to like that one anymore. I must be too childish.
It's too much.
It's all right. Okay, produces. What does that make? What information in the question, if I continue to read through it, it says that we make water. Am I responsible to know that water is the formula H2O? Yes, unfortunately I am. Okay, here it's not specifying the phase, so we might just go through and throw a phase in there. What phase do you think we'd throw in? Probably a liquid, because the standard state for water is a liquid. Okay? We now have a chemical equation. But is this a balanced chemical equation? No, so what do we have to do? We have to balance it. Okay? Now that it is balanced, I can interpret information from it. I can show how to convert oxygen, which I will place in the denominator because I want it to cancel with the other oxygen. And what substance do I want in the numerator? Why water in the numerator? If we look to our goal, the answer, H2O, is located in the numerator. What is the unit associated, the measurement unit associated with a conversion using a chemical equation? 3 valid answers. Moles, molecules, and accounting. Okay? Does it make sense to use molecules? No. Why does it not make sense to use molecules? Well, but does the question say anything about moles? Okay, we're given grams. So really, why would I use moles over molecules? Nope. Maybe. What are you suggesting? Moles are easier to measure. Why? How do we measure our substances? In mass. And what's the problem with measuring molecules? They are too small. We can't actually get a legitimate measurement. So we measure instead a massive number of molecules so that the mass becomes reasonable. What mass are we working in? 9 grams. Is that a reasonable mass or a stupidly tiny mass? That's a reasonable mass, which means more than likely I'm working at moles. What are the numbers associated with those units? Okay, 2 to 1. How'd you get the 2?
2 is in front of H2O.
2 is in front of the H2O. Whoa. And 1 is in front of the O2. The problem with using this conversion factor, anybody see an issue with it? When we do our conversions, typically what are we trying to do? Okay, we want units to cancel out, or units to appear. Did that conversion factor cause any units to cancel out? Did it actually get me grams of water? No. So this conversion factor I know needs to show up, and I know it needs to show up in this fashion, but it doesn't simplify my expression. So that is why people typically don't use it. Right? They usually shift it to a different step. But the reason they were allowed to shift it to a later step is they made that blanket statement, I just want to be in moles to begin with. And as soon as we make that statement, you're either trusting somebody else that they did the answer right, or you have a solid understanding for what you need to do.
But are you making that same assumption about
No. Why are we placing moles in here?
Because you want to use it as a unit of measurement because that's a reasonable mass. But can't you just make that same assumption by doing the equation that me and Molly did?
But why were you using the grams to mole conversion?
Because I knew that when you're referring to grams, then moles are a reasonable way to measure it.
But you don't know that you have to be converting to moles. Because I could have been converting to molecules. So there was no context to explain why grams to moles made sense. I could have been going to molecules. I could have been going to atoms.
But isn't the reasonable measurement of 9 grams like enough to imply that you're using moles instead of molecules?
So what you're jumping is saying that the moles were our issue. The moles is not where we brought this in. This conversion factor did not start around moles. What did it start around? The substance. Recognizing the value of the substance conversion. Once we had the substance conversion in the chemical equation, we then had to remember the units associated with it of a substance equation, which gets us moles. Okay? And we could, and I'm not disagreeing that the conversion factor that you chose isn't wrong. The placement of it isn't wrong. It comes down to the logic behind why it's there. That logic is shaky ground. If you're happy with that logic, that's okay.
Do you want to hear what my logic was? So?
Not yet. Okay, we can talk about it after class. Okay. So now what happens? Our nice simple equation that only had 1 unit now has 3 units. What do we need to do? Get rid of some units. What units do you want to try and get rid of? Okay. So there was a suggestion to get rid of the moles of O2. So to get rid of that, I would have to place the moles of O2 in the numerator. Why? So that it could cancel the units in the denominator. Okay. What do I want to convert the moles of O2 to? Well, not even necessarily convert. Am I given the moles of O2 anywhere? No. Okay, so I can't just plug in a number there. I'm going to have to do a conversion. What do I choose to convert to? Why grams? I want grams in the answer. So take a look at my answer. Where's my measurement unit of grams? Numerator, denominator. Numerator, where did we just write grams? Denominator. So because you want grams in the answer is not a valid explanation for why we're placing grams of O2 in the denominator. If we look further back through our equation, we have grams of O2 in the numerator. I don't want the grams of O2 in the numerator. That would cancel. That's why that grams of O2 is awesome. Okay. Where do I find that conversion factor? This comes from the periodic table. So I would look for the element O2 on the periodic table. Does the element O2 exist on the periodic table? No. What does exist on the periodic table? O. How do I get O2? I would multiply that number by 2. And because we're all lazy in rounding, we're just going to say 32 grams is 1 mole. Why do I know the 32 goes with grams? Because when I look at the periodic table, it says 16. It doesn't say 16 grams. How do I know that 16 is tied to the gram unit and not the mole unit? So one option, you're supposed to remember that. Fully accept it. Another option. That 16 is what? The atomic weight or mass. What is your measurement of mass? Grams, which means that should be 16 grams. That's how we know the number is tied to grams. The information is encoded in the table. Okay. Would we have our answer? Why not? Okay. I need to get rid of the moles of H2O, and I still need grams of H2O. Where do I find that conversion factor? The periodic table. So where's the element H2O on the periodic table? It isn't there, so what do I have to do? Break it down into all the pieces and add it up. And since we're horrible at rounding and ignoring sig figs, we can write 18 grams, 1 mole. What happens with all your units? The moles of H2O cancel, and we would have what units? Grams of H2O. What were we trying to solve for? Grams of H2O. What have we done? We solved it. Now it's a question of punching it into the calculator. Gently, so you don't break your calculator. I don't really care what the number is. Is it 10-ish or is it 20-ish? 10-ish. Is that the 10.1? 0.125 or 0.125? Okay. Just to be extra irritating, is 10.125 the correct answer? 10.125 grams of H2O, is that the correct answer? No, because mother effing sig figs. We look at our 9.0. Our 9.00, grams is 3 sig figs. 1, 2, 3. Our answer becomes 10.1 grams of H2O. Okay? And a show your work or a short answer, you absolutely would need to be writing 10.1. If you finalize your answer as 10.125 or even 10.13, you would lose points because that's not fully correct. Okay? So, I'm going to state it again. We spent roughly half an hour to go through and solve that single question. The answer is now on the board. The answer is not what you should be copying down. What you need to be copying down is the process behind how we did that. Why did you use those conversion factors at those times in those places? That's what helps you solve this. Okay? If you try to just copy the answer, what's going to end up happening is you will solve your questions incorrectly on the exam. How incorrectly? It will depend on the number of conversion factors tied into it. This one's running 3 different conversions. Each of those is a 50%. So you're looking at 12.5% chance of getting this question right. Okay? You need to know the why behind each of those. You good? Okay. Yes. Yes.
So we had switched. We just had, ours were just in a different order.
Does the order matter?
Theoretically, no.
No.
As long as you have
It's not even theoretically. It literally doesn't matter. It's all about your reasoning. As long as you have a legitimate reason to place them there, you're okay. What comes down to the issue is what is legitimate. Solve 20 questions. If your reasoning holds true for all 20 questions, guess what? It was legitimate. If your reasoning holds through for 15 of 20 questions, starting to be questionable. Are you okay with 15, what is that, 75%? Are you okay with a 75% on the exam? Yes? Then stick with your reasoning. Okay? If you're not okay with a 75%, you need to change your reasoning. Okay? And that's where it becomes challenging. Okay? We're really pushing it, running enough questions to force you to find the flaws behind your reasoning. Okay? Make sense? Okay. So we attempted to show some other method. We can show that other method. Remember I showed you what's the relationship between these? Okay, we can do that. It becomes a lot harder with this one. Why does it become harder? Okay. When we talked about that other method, it was taking the numbers from the balanced chemical equation and showing the conversion. Okay? But that requires moles. Am I starting with moles? No, I'm starting with 9.00 grams of oxygen gas. And I want that to become moles of oxygen gas so that I can do my conversion from the equation. Okay? Is there a relationship between the grams and moles of oxygen? Yeah, where's that relationship found? The periodic table. And that periodic table tells me 32.00 grams of oxygen gas equals 1 mole of oxygen gas. How do I go from 32 to 9? So, 32 times what equals 9? Work with me a little bit here. Don't give me the fraction or the decimal. Give me the fraction. 9 over 32. So I would take 9 over 32. Right? Literally, just solve right there. Okay? Look down at our bottom work. 9, 32. 9's in the numerator, 32's in the denominator. What did we just do? that exact same thing. Okay? So if we're doing 9 times whatever that you gave me a fraction, 9 30-seconds to do this conversion, how do we go from 1 to x? Okay? Times 9 30-seconds. Okay? I now know the moles of oxygen. Okay? I know I have 9 30-seconds moles of oxygen. Okay? Yeah, I don't like this either, but at least one other student that I've seen has been like, yeah, I really like this, and it confuses the crap out of me. Okay? How do I go from 1 to 9 30-seconds? What did I do? Times by 9 30-seconds. So what do I have to do the other side? Times by 9 30-seconds. Okay? So my moles of hydrogen becomes 2 times 9 over 32. Yeah? Look at our equation down below. 2 times 9 divided by 32. Okay? So what we're doing is a proportional reasoning for all of these. I'm literally out of space and I can't throw in the next conversion. Well, I could try and squeeze it in. Do you guys want me to try and squeeze it in there? Oh, you jerks. All right, so our last conversion, we have 2 times 9 30-seconds. Oh, and of course I did the wrong one. I went to H2. Yeah, putz monkey. Right? Moles, H2O. What am I trying to convert the moles of H2O to? The grams of H2O. Where do I find the conversion factor between moles of H2O and grams of H2O? Periodic table, 18. Whoops. 1 mole of H2O is 18 grams of H2O. Okay. How do I go from 1 to 2 times 9 30-seconds? We'll just multiply by that number. So what do I have to do to the other side? Multiply it. So my answer becomes 2. So let's run through this. My answer becomes 2 times 9 times 18 divided by 32. You mean all of that work does the exact same thing as this single line? Yes, that's what's beautiful about the single line. All of that work was 3/4 of a page. Okay? The single line establishes those relationships and allows you to solve for it in a single, simple system. Okay? Without having to individually say, how do I do each and every single conversion? Okay? With that, take 15. We'll come back, well, a little more than 15. We'll come back at 105. And then we're going to speed through a bunch of stuff.